So hello, everyone. My name is Yuval Boger. I'm Chief Commercial Officer of QuEra Computing, and I'm very pleased to welcome you to this edition of Quantum and Friends, part of QuEra's World Tour, this time we're in Germany or German-speaking countries. And I have three wonderful guests and friends, Jan from Kipu Quantum, Alexandra from QuAI Ventures, and Marcus from QMware. Hey guys, how are you doing?
Fine, Yuval. Hi. Thank you. How are you doing?
Living the dream. And of course, each of you will present for a few minutes. What we're going to do is I'll give a short introduction of QuEra and why we're here. And after that, Marcus, I'll ask you to share a few slides about QMware, and then Alexandra and then Jan. We have a Q&A box in the webinar, so anyone is invited to submit questions, and we'll try to answer them as we go or at the end of the presentations. This is really for you. So again, here are lovely pictures of our participants. Jan, your role at Kipu Quantum, you are, remind me please?
I'm head of development, so I'm responsible for algorithms.
Wonderful. And Marcus?
Similar, the same, head of development, but I'm responsible for the platform. So we are not so much in algorithms, more in the platform.
And Alexandra, how about you?
I'm leading the company QuAI Ventures as a CEO.
Wonderful. All right. So let me tell you a little bit about QuEra. So QuEra is located in Boston, headquartered in Boston. We do have offices in the UK and also in Japan. We were founded out of Harvard and MIT, and we have close partnership with them. QuEra builds quantum computers with neutral atoms, and many consider neutral atoms to be the most promising approach to achieving true quantum utility. Our first computer is accessible on AWS, on the Amazon Cloud Service, since November of 22, and we're also installing on-premises computer. Very recently, we received a $230 million investment led by Google and SoftBank. And some people say, Google, don't they have their own quantum program? And they do, but they also decided to make an investment in QuEra. And we partner with enterprises, HPC centers, and governments to help them in their quantum journey. We'd like to think of ourselves as the quantum innovation partner. And we see these three groups of companies. We see enterprises that believe that quantum computer will redefine their industry, and they want to be in the lead. In short, they want to use quantum computing to gain competitive advantage. We see HPC centers that want to solve problems that classic computers can't handle. So they want to serve their customers and want to solve intractable problems. And we see governments that say something like, we want to build a tech hub that attracts talent, research, and industry, essentially using quantum computing as a seed for economic prosperity. So whether it's a competitive advantage, solving intractable problems, or generating economic prosperity, we can help. And how do we help? Well, we have three offerings. The first one is quantum systems. So we can deliver computers, whether on premises or via the cloud. We have what we believe is a breakthrough architecture using all the wonderful things that neutral atoms have to offer: room temperature operation, scalability, all-to-all connectivity. I mean, we can get into the details all day, and we're happy to get into the details because we're very proud of them. And together with these systems, we provide installation, support, and community development. We also perform collaborative research. We have best-in-class error correction. We created quite a firestorm in the industry at the end of 23, demonstrating in a Harvard-led research 48 logical qubits, and then early this year, magic state distillation on logical qubits. We developed novel algorithms. And we collaborate with leading universities, of course, Harvard and MIT, but not just Harvard and MIT, many others throughout the world. And we offer a unique offering that we call algorithm co-design. This is typically an 18 to 24-month collaborative process where we work with customers hand in hand to do full stack optimization, basically to do a complete life cycle of a problem, from identifying the problem, selecting which problems could be useful for quantum, designing an algorithm in all levels of the stack, simulating, and then ultimately running it on one of our advanced quantum computers. And we're not doing this alone. We launched what's called the QuEra Quantum Alliance, which we believe is sort of the best of breed partners that can help us. We are experts in quantum computers, but our partners bring so much expertise, and it's not a surprise that three of these partners, QuAI Ventures, Kipu, and Kipu Quantum and QMware, are with us today to showcase their unique capabilities and how we work together to help customers achieve their goals. Interesting bit of news. This is a photo from GTC, the big NVIDIA conference a few weeks ago. You see here Professor Misha Lukin from Harvard University, scientific co-founder of QuEra, meeting on stage Jensen Huang, CEO of NVIDIA. This was in the context of a couple of things. One, NVIDIA inviting quantum leaders to talk about the future of quantum and how it's coming. But NVIDIA also announced the NVIDIA Advanced Quantum Center in Boston. And we are proud to be founding collaborators. This is located just a short distance from QuEra, about 30 minutes by car, and we're both very happy that it is being constructed in Boston. But we also don't think it's an accident that it was constructed in Boston. I hope we had a nice part in that. And what we're going to do is collaborate with NVIDIA on GPU and quantum integration. NVIDIA published a technical blog about work that they did with us about using AI and quantum. They used AI for a quantum error correction decoder. And we're also looking to bring in customers, strategic customers, for a three-way partnership to really push the envelope on what can be done on a hybrid system, on a quantum supercomputer, or on a quantum accelerated supercomputer. So we're very excited about that. And I think it's one more part of what we believe is our commercial and scientific leadership in quantum. Where are we with quantum today? I mean, in my mind, the industry has gone or is going through three phases. It was not that many years ago that the question was, can quantum computers actually work? I mean, people said we kind of understand the physics, but can you build something even with 2 qubits and show entanglement and so on? Well, that, of course, the answer is yes. Dozens of companies have built quantum computers with different modalities. And then the next question was, can errors be corrected? Because if quantum errors cannot be corrected, then you're limited in the length of the calculation that you can run. And if you can't run a long calculation, then quantum is not going to be very useful. And we, as well as others, have answered that in the affirmative. I mentioned 48 logical qubits, and other companies have shown logical qubits. We demonstrated magic state distillation. And so I think most people believe that, yes, the answer is yes. So now we're at the point where we say, okay, can we scale computers to be truly useful? And what we see is that many analyst organizations believe that based on recent progress, then truly useful quantum computers could be just 2 or 3 years away. And so the big question is, should I wait? If it's 2 or 3 years away, I can come back in 2 or 3 years. And you could wait, but we believe that the risk of waiting is much greater than the cost of preparing, because preparing for quantum and the quantum revolution takes time. You have to identify the problems that benefit from quantum computing. You have to build the right team and find the right partners. You have to upskill your team members. You have to develop, simulate, and test quantum algorithms, compare them against what you do classically to make sure they work well. And of course, identify the right partners. And this is why we look at ourselves as innovation partners for this. So since I used the word partners several times in the last minute, then let me turn it over to our partners. And Marcus, perhaps you could share your screen and tell us a little bit about what QMware is doing and how we might be able to work together.
Thank you, Yuval. So let me see how I can share this. Does this work, or is that too small?
It does work.
Okay, great. Yeah, hi, I'm Markus Buchberger from QMware. I'm based in Germany, in Munich. QMware itself is originally a Swiss company, but it has locations in Austria and Germany as well. And at QMware, we are focusing very much on the integration of quantum computing with high-performance computing. QMware is a joint venture of Novarion in Austria, in Vienna, which is a company who is building and equipping data centers in the area, in the domain of high-performance computing. And the other joint venture partner is Terra Quantum from Switzerland. They are doing a lot in algorithmic. And so at QMware, we now try to build the bridge, let's say, between the high-performance computing data centers and the people and the companies who are investing and researching algorithms for quantum or hybrid quantum computing. So our goal is to merge quantum and high-performance computing together. And we want to achieve that with what we call quantum hypervisor, which is a term that is known in the high-performance computing community. The term hypervisor is known, and we want to extend that to bring in and to integrate also quantum processing units into this world. The product where we want to offer this kind of service is a cloud native product which offers an API that enables customers to use our hybrid heterogeneous quantum computing capabilities. These cloud services are offered either via our own data centers. We have 2 data centers, one in Vienna, one in Munich, or we even deploy these cloud services in the hyperscalers. At the moment, we are working together with Oracle Cloud Interfaces and with Ionos in Germany. For this heterogeneous hybrid quantum computing processing, you can find here a link to a white paper from QMware where we describe this model, this computing model, and we also filed a patent for this in the US. Data centers, as I said, QMware is owning 2 data centers at Vienna and at Munich in Germany. We have some things going on in Enschede in Netherlands, together with Quix, and also in Berlin, together with Ionos. And we also have it in our plans to start something in Boston, which we discussed with Yuval already some time ago. And I will explain a little bit later why we are focusing on data centers close to vendors or providers of QPU services. Our product is called Execute. It's a cloud-native API which allows developers, enterprises, or data centers to access hybrid quantum computing capabilities via our cloud services. The quantum processing units can be remotely. They can work somewhere else, and they could be accessible also via other cloud systems like AWS or Google. But we also having direct integrations, direct partnerships with QPU vendors like Rigetti, IonQ, D-Wave, or IQM, where we have integrations on a level 1 or level 2, what we call them. So here we have integrated their services or the handling of their REST APIs into our SDK, and we provide it via our platform Execute. Then we have closer partnerships with other QPU vendors like QuEra, Quix Quantum, Equinix, also with NTT. They are not really offering a quantum computer, but they are offering simulators. Where we have deeper integrations, we call them level 3 or level 4. And these are the kind of integrations where we try to bring the high-performance computing hardware, which is needed for the classical pre- and post-processing and hybrid quantum algorithms, very close to the QPU vendors or to the QPUs, where they are located in the data centers, to have a low latency connection to the QPUs so that we can bring performance to hybrid quantum computing algorithms and to be able to run classical code in parallel with a QPU algorithmic and try to decide classical or try to run classical code while a QPU, for example, is in superposition. This is then called QPU integration level 3, level 4, where we work very closely together with QPU vendors, and that's also where our hypervisor, our quantum hypervisor, comes into the game. At the moment, when we see what is available on the market, a lot of access to quantum processing units is are available via multipurpose clouds, via AWS, via Google, via Azure from Microsoft. And very often here, there are workflow managers, we have HPC resources, we have virtual compute power, storage, and so on. And then there's a quantum cloud gateway, which then uses quite often REST APIs from QPU vendors. Our vision is a little bit different. We would like to integrate QPUs directly into our system by putting our hardware into the data centers where QPUs are installed. This becomes now even more relevant as the European Commission has now decided or somewhere in 2024 to invest quite amount of money in building up data centers for AI. And there are, I think it's now 14 data centers which are built in the European Union. One is in Jülich in Germany, and others are in Poland, in UK, in Spain, in Italy, and so on. And I'm not sure. I think it's not only by chance. I think there is a relation that some of these data centers where AI services should be implemented and should be made available for the European industry are very close, or are even the same data centers where also quantum computing vendors did already deliver their hardware. So, for example, in Munich, in the Munich Quantum Valley, or in Jülich, we have installations from quantum vendors, for example, IQM, but also from IBM and others. And this is where we try to get the best in class performance by having high performance computing scenarios within memory processor virtualization. And we want to integrate there not only the classical GPUs and CPUs, but also quantum computing controllers into that scenario that then connect to quantum processing units of different topologies. Another idea in this product is also to have an abstraction layer over the different topologies of QPUs which are available on the market, so that we can have a homogeneous and consistent programming model over that. This technology, or this module, we call QMware Quantum Hypervisor, and this is a small architectural picture here. So here we have several different QPU vendors which we are partnering with, and here we have different kind of integrations on a different level. And when it comes to the quantum hypervisor, we are talking about integrations with level 3 or level 4, where we are working closely together with the different QPU vendors. We have some partnerships running with quantum hardware partners like QuEra, Rigetti, IonQ, IQM. We have also partnerships running with classical HPC partners. We have a partnership also with NVIDIA. We have a partnership with Jülich Forschungszentrum, where they are building now the first exascale computing center in Germany. We are also partnering with Leibniz Rechenzentrum in Munich. We have cloud customers. In Germany, we are strongly partnering with IONOS, which is one of the German cloud providers, but also with Oracle. And then for research and education, we are partnering with Fraunhofer University in Vienna, Technical University in Vienna, Technical University in Munich, University in Stuttgart, and the DLR, which is the German aerospace company in Germany. We want to address several pain points of the industry. So one pain point, in our opinion, is that we have different kinds of quantum hardware which is available on the market with complete different technological architectures. And they might also have different kind of programming models, which we want to address. Another challenge is need for investment for security. And especially in Europe, we have high standards in data privacy regularies, which we want to address with our products as well. So these are the three main pain points that we see in the industry. And with our unique solution, we would like to address and solve all these pain points for the industry worldwide. But as I said, especially for Europe, because I think in Europe, we have a very special situation when it comes to data privacy standards. So we are able to provide best-in-class hardware with access to the best QPUs and classical hardware when we combine high-performance computing, classical high-performance computing with the available best-in-class QPU vendors. And therefore, the close integration and the close partnership with the QPU vendors is very important for us. I have no idea, Yuval, how many time did I spend already? I forgot to look on the watch on the time.
I think you're good. This was very interesting. So
may I have 1 or 2 minutes more?
Of course.
Okay. So I think one topic which is very, very it's a hype at the moment is AI, artificial intelligence, and quantum AI is, I think, a very, very interesting topic where we can combine quantum computing power with the need of AI, which is and everybody is talking about that at the moment. We are already active here, so Jan might know some of the stuff here. So the project Sequence, the German Quantum Cloud, is a project that is funded by the German government, where we are working together with partners to show how we can make quantum machine learning and quantum optimization problems available for the industry. Also, Planck integration was part of that project, Planck, which is now mainly Kipu Quantum. Planck was the, let's say, the research and educational root of Kipu, if I may say it like this. Also, the project Quantum Ready, which is something similar in Austria. It's also founded by the Austrian government, where we also focus a lot on enabling quantum machine learning for the industry. And one thing might be interesting now for this specific context, because we are here now at QuEra and we are talking about QuEra. As I said before, QMware is a joint venture of Novarian Systems and Terra Quantum. Terra Quantum is offering their platform, TQ42, where you can access their quantum machine learning environments. And here you have the possibility. I will now not play the video, which is 1 minute 30, but maybe give you a short impression. With that platform, you can with a very comfortable user interface, you can select what kind of model you would like to train. You can combine classical layers, classical neural network layers with quantum neural network layers. You can parameterize them. You can control the number of qubits, the number of layers, and so on. And then you can also model, train the models. You can train also the hyperparameters optimizations and things like that. At the moment, on the TQ42 platform, we are training the models with classic compute powers, so with simulators of quantum computing. And then you can execute or you can run the inference part on real quantum hardware like IonQ, IQM, IBM, Rigetti, and so on. And here, this is a research topic, and I'm not allowed to tell too much about it, but we expect this year to have some publications here and some progress. We are also investigating how to use reservoir computing and quantum neural layering with reservoir computing via the QuEra Rydberg quantum hardware. And I just wanted to mention this. So we are, or our sister company is actually in a research project where we want also to analyze what capabilities can we have if we are using the analog models of QuEra, which is available today already, and which gives you a quite big number of available qubits. Okay, that was my part. Thank you so much.
Thank you very much, Marcus. And I think you're right. Quantum reservoir computing is very interesting. And in the context of German partners, we published not too long ago a work together with Merck KGaA, Darmstadt, Germany, as well as Deloitte and Amgen, showing that quantum reservoir computing is useful to analyze clinical data, low volume clinical data, and actually outperforms classical machine learning in those scenarios. So with that, Alexandra, the stage is yours.
Thank you so much, Yuval. Can you see that? Can you see my presentation?
Yes.
Perfect. So thank you so much for the invitation, Yuval, and welcome everybody. I love actually what you do here, bringing together your friends or the ecosystem. This is also actually what QuAI Ventures is doing. So we position ourselves as an ecosystem orchestrator in the quantum field. We have two different instruments to build this commercial quantum ecosystem, and this is a venture capital fund with which we invest into startups that build the technology. And we also run an accelerator as the instrument to bring all the main players that it needs to develop the technology together. As I saw a lot of people that I didn't know yet on the list, I start from the very beginning. So there might be people amongst you that listen to this presentation already a second time, or that already know a lot of stuff that I'm talking about. I would like to go a little bit, only one slide, into history, how everything what we do started. So we are QuAI Ventures. We're also based on the very south of Germany, I would say, in Switzerland. We were born out of an innovation campus that started 5 years ago with the goal to give new technologies a place to develop. Myself, I was working in the strategy development of this campus, and we were working on the strategy of building up quantum technology stronger with private money, not governmental money, that to build up this technology in Switzerland. We started with first partnerships on this campus. We are one of the few IBM hubs worldwide. We also have an IonQ computer here on ground. We also have a collaboration with D-Wave on this ground. And this is exactly when QuAI Ventures was founded, because I stepped back and I said, this is a nice approach, but this is not yet a real business model, right? The technology doesn't work yet. So what we are doing is we are starting partnerships with hardware providers. But what actually are we selling? Yeah. 3 years ago, there was not much to sell. Now it's changing. But I said, if we really want to develop the technology, we have to develop the companies that develop the technology. We have to focus on startups. And this is how QuAI Venture was founded. I think this is important to understand. Today, we are based in Basel. And today, we are 10 people. We are 10 people in Switzerland. We are 3 people, I will tell you later more about it, in Japan. And we are 3 people also in Canada. And what we offer today is several programs to accelerate startups. So we have a typical accelerator program. We already enter in total 4th batch just right now. We also have other programs to educate docs, PhDs and postdocs in the university to teach them how maybe to start their entrepreneurial journey. We do a lot of hackathons to start even before that, to get students from school engaged with quantum technology. And then, of course, as we now also start to invest in later stage startups, then we have some programs for scale-ups. We invest with the first fund in early stage companies. And we are now in the process of building up a growth fund that allows us to invest into later stage companies from Series A on. So if there is companies amongst the audience for that could be interesting. So we're happy to hear from you also. When we talk about ecosystem building, you see it on the left side. This is the stakeholders you might all know. This is what we believe that it needs to develop an ecosystem. We need universities where the knowledge comes out, but also, of course, the talents. The talents come out for the startups, for the new companies that are created. We need the entrepreneurs that need our funding or funding from other investors. Then we need the corporates as the users of the technology and the first customers of the startups. And then, of course, we need the startups that develop the technology. This is what we believe that it needs, and this is what we orchestrate and bring together. I mentioned it, we started in Switzerland. We are based here in Basel, but we believe that quantum development is a global game. Quantum is not only developed at one university, not only in one region, it is developed in main regions worldwide. And this is also where we are based. You see a lot of pins. So we have only 3 offices. The other pins, it's more to show the global ecosystem with mentors and hardware providers and other partners that we have. There is not all the regions marked that are important for the quantum development, but we're also only 2 years old. So bear with us. We are on our journey, but we focus on the region where quantum is happening. That means it is important also for me to say we don't go to the regions that has most of the money, or where the government invests most of the money in quantum. For us, it's more where is the best universities, where is already innovation ecosystems exist, where is good spin outs from universities, where is an innovation infrastructure already existent, where we then as QuAI Ventures can come in and orchestrate the ecosystem and build up on the basis that already exists. We just launched an office in Japan. This happened a few weeks ago. Interesting for us in Japan is the corporates. The corporates in Japan are very open to use quantum technology. And they are the reason why we entered this office actually there. They are interested in working with us. We are in Calgary because the interesting part of their ecosystem is that we have a collaboration with the University of Calgary. Calgary is now becoming I think the most influential or most important hub in Canada. They are at this moment boarding on 15 new quantum physicists at the universities. The government highly supports the development of quantum and other technologies like data centers with a lot of investments in the region. So this is why we are there. And as you see on the map, we are already also reaching out to Singapore and discussing to set up a program that is focused on a vertical, on an industry vertical. I talked about ecosystems. I know this looks like a lot of logos. I just want to show examples with who we worked. It's not that this is all our partners, but they have been partners in some of our activities. For me, this is important to show that we really want to engage with all these five different players in an ecosystem, and the offer that we have, or we always say our customers, we have different customers, right? We have a startup that are our customers, we have corporates as our customers, we have investors, and then we have hardware providers as customers or partners. So they are highly interesting for us. So also QuEra, for example, was our first hardware provider as a customer. We offer startups to enter or to enter a collaboration and to get hardware access to the QuEra machines, but also to the QuEra engineers behind the technology. We have actually, when I just went through the slides, there is missing already some people. So this is just an idea to give you what I always like to show is that we have an investment team, but we also have, I always call them a value creation team. So we have a smaller investment team than a value creation team. Value creation team for me means as soon as we invest into the startups, we actively work with them. We try to get them partners. We open the network. We connect them actively to other players that they need. And of course, we mentor them in an accelerator program. And this takes more than half of our activities. We work with a lot of mentors, also out of the quantum industry. I think this is important. Quantum, when you develop a startup, it's not only another deep tech technology. It's very different. The market is very different, and you need to have people that know the business, that not so much the technology. You might know, your technology much better, or startups know their technology, of course, better than anyone else. But it needs people that come out, that understand the technology and has scaled already a business. So mentors to mention is the co-founder, for example, of IQM, or ex-CTO of Rigetti, Michael Harburn. Then we have, of course, also IP lawyers that have that are quantum physicists, and so on and so on. So this is just an example of the list. This is the mentors that we not only provide to the startups, but also to our industry partners. That's brief overview of the investment portfolio that we have until today. We invested into over 20 startups until today in early stage. I can answer questions to it, maybe one-to-one if you have questions to it, just to show you. So we invested into more than 20 startups out of every industry in quantum sensing, communication, and computing. And as we see, the market is developing. We talked about quantum and AI, the influence of AI and quantum. We opened up the investment thesis in the way that we also invest into technologies that help quantum to scale. And this is quantum AI, and this is other kinds of advanced computing. I mention it, no matter if you're a startup, a corporate, an investor, or a hardware provider, we would love to work with all of you, connect all of you. I think Yuval knows it very good that we are thinking long-term. So it's not about making a partnership contract and then do something. No, we just start to work, find out what is the best way to work together. And then maybe later we can do a contract on it if we see the value for both sides. What we offer is, I said already, we offer an accelerator, we offer 2 funds. And we are working on 2 new offers. One is a commercial platform, meaning that everything that we now do, one-to-one sharing this ecosystem, you will have access to on a platform, seeing use cases, seeing partners that you might want to work with, and so on. And we also offer this. We already discussed with Kipu Quantum, for example, as one of our portfolio startups, to also use our platform to offer their services to more customers. Yeah. And we realized in the industry, this is happening right now, that the industry is not so much, or not, they are more interested in having very precise information on the industry clusters they are working in, and not on quantum technology in general. So we are asked now to build up industry clusters focused on finance, focused on life science, or focused on energy. And this is what we will launch now. I triggered it a little bit on the first slide, and I think we are as far enough to talk about. So we think about building a cluster like this in Singapore first for finance, and then as we are in Canada also, where the industry of oil and gas is very strong and they are looking for new investment opportunities, building a quantum for energy cluster with partners. So the accelerator program, how does it work? The program runs for 5 months, where 4 weeks are on stage. We try to engage the program is of course made for startups, but we try to use this program also to target corporate partners. Corporate partners, what do they get from it? They get, of course, the access to the startups. They get first use cases to work on. We see a lot of huge corporates. They don't have quantum groups, or they don't develop quantum groups internally. They want to have access to our startups to develop first products. And what we see now, and this is a new development, I don't know if you can share maybe on this experience. We also get approached a lot by companies to have access to the talents in the startups. Yeah, so interested in investing or buying startups just to have the talent. Early stage fund, late stage fund. It's a typical investment fund where we can invest up to late Series C with the second fund that we are building up right now. Global focused, only private money. Strong LP base from Japan until now. And this is what we're going for. The digital platform I was talking about, we are building up also with one of our partners. So we don't only offer access to quantum computing, we also offer access to AI infrastructure, and we also offer sovereign cloud access. And this sovereign cloud and AI infrastructure is hosted by one of our partners called Phoenix Technologies, and they built up the platform that our partners can have an easy access to the services of our partners, the startups that we're working with, that they have also easy access to hardware providers like QuEra. That's of course also the goal, that not only the startups have access to to the hardware providers, but also the customers of the startups then. Yeah, this is what we're looking for. And I talked about it already, the global curated industry clusters. When I talk about energy clusters, maybe in Canada, and finance clusters in Singapore, we never think in countries. We always think globally. Maybe I can also, it's my favorite example at the moment. So we accelerated a startup that was actually based in Calgary, came out of the laboratories. They wanted to be accelerated in Switzerland to have better access to the European ecosystem, and they have now a partnership with one of our Japanese industry partners. Yeah, this is how we think, how we work. Also, building industry clusters. We focus more on the topic than on the global location, and we also focus less on startups, but more on, like, from a customer base, more on corporates that want to have access to what we do. And the startups, of course, they can they get all the value out of it, because they get to know the corporate partners that want to work in this specific area. We do much more. This is just some examples. We do nice hackathons. If you want to do a hackathon with us, this year we will have 3 hackathons. We call it the World Series of Hackathons. It sounds a bit fancy, but we named it as fancy as it is also the year of quantum. Hackathons will be in Calgary, Canada, in Switzerland at the CERN, and actually the third one I just forgot. I will tell you later. So we have 3 hackathons this year. I really forgot. I will tell you later. Besides these other services like what I talked about, hackathon and other events, we really provide you with services that you can grow your knowledge. We do venture building programs. That's also new. You might not have heard about this. That's also an activity that we start because we see in the market the movement that corporates, they don't find maybe the solutions that they want on the market, but they want us to build the solutions around a patent, setting up a team, and then buying out the solution for their company. That's QuAI Ventures, and I think that was an overview of what we do. Join us, reach out to us later. I'm happy to answer any kind of your questions. Thank you so much.
Thank you very much, Alexandra. You invested in some wonderful companies, but one of our very, very favorite ones is Kipu Quantum, and we have Jan here to present what they do. So Jan, please, if you could give us the next 10 minutes to talk about Kipu.
Yes, for sure. Can you see my screen?
Yes.
Perfect. Thanks a lot. Before we dive a little bit deeper into the topic, I would like to give you a brief introduction what Kipu actually is. So we are a German-based software startup that's specialized in bringing quantum algorithms on hardware and creating value as soon as possible. And we believe that we can leverage actually the newest hardware in the best kind of way if we combine software specific applications and creating our algorithms hardware specific. And with this, we believe that we can bring value to quantum computing to solve industry relevant problems very soon. So how are we actually doing this? One of the biggest problems currently that quantum computers are having is that they only have limited coherence time. So if you, for example, think of digital quantum computing, is that you have to execute many, many gates, and then you are in the case often too long for the coherence time, so you cannot measure anything. And what we at Kipu are doing is that we are creating our algorithms application specific and also hardware specific. And with our technology that is mostly based on counter-diabatic terms, we can actually reduce the circuit depths by a factor 10 to 100 or even more for specific problems. And with this, we are able to leverage the complete quantum hardware and can then tackle industry problems on a specific size and probably with the next hardware generations, even on the quantum advantage level. We believe that we are, in recent studies, we found that we actually approaching the quantum advantage level. With this we mean that we are able to see instances where our quantum solutions are performing equally well, or in very specific instances are even better in terms of, for example, speed or solution quality, or even have lower costs for certain applications than the classical counterpart. We mostly have 2 major streams that we focus on. One is optimization, where especially we are currently seeing or that we are able to outperform certain higher order instances, that we are able to outperform CPLEX in terms of speed. These are very special instances. So we are not claiming that we outperform now all classical solvers, but we see a potential there that with the new hardware generations, we are approaching actually that level and that we can bring quantum advantage to industry really, really soon. Another thing that we are focusing on is quantum machine learning. There we also had a very similar finding that Yuval already has mentioned together with Merck, that actually quantum is able to boost the performance of classical machine learning models in terms of the quality, or even is able to reduce the costs because the classical machine learning doesn't have this much classical parameters anymore. About this, I will speak a little bit later. For now, I would like to focus on one project that we did together with QuEra in the optimization framework. There we will focus on increasing the resilience of a telecom network of a customer in Spain. For that, for example, I would like to introduce what actually is network resilience. So we had a customer that had a very broad network in the system, and now they would like to know how can we optimize our network by, for example, introducing redundancy to make this more error prone. For this, we would like to have here a look at the network. This is an intact network, but what happens if, for example, this city here fails, or this connection here fails? Because we have here this random connection, nothing would happen to the network. We would only have limited affection because only one city is out of the network and the rest could still be connected. But what we also can see, if, for example, we have the city here in the center, there is, if we are here an outage, the full network would break down and would lose all the connection in the network. And this is now a task that we would like to quantify by using neutral atom systems. We choose the neutral atoms because actually the network was pretty huge, and this was the only system available where you could get the connectivity and also the number of qubits to solve that kind of problem. And we did this by actually mapping the network on finding the MIS solution of the analog quantum system of QuEra. And we can do this by mapping the network as a graph, and then we can find the maximum independent set. And this maximum independent set allows us to quantify the resilience of this network. The very interesting part of this was that we were able, using 150 qubits of the QuEra device, that we were already able to solve 10% of a realistic networking system of MassMobile, which is now a part of the Orange group. So they gave us the network. We simplified it as a backbone, which is like the major and the core component of the network. We then mapped this to the Aquila device, introducing some gadget qubits to establish the connectivity. And from that, we got then the maximum independent set solution, which we then translated back onto the network. And from this, we got then network resilience. And for us, this was a super important project because with this, we could already demonstrate that with the current devices, we can solve a realistic pilot. And also because we're able to solve 10% of the network, this also means that we will be able to tackle the full problem within the next generation of the hardware. For us, it's also important that we can prove now that nowadays quantum computers can already tackle problems of decent size or sub-problems in network optimization. What this means, for example, if you now put this to telco, you can boost the customer experience at scale because you're now able to improve the resilience. And if then something fails, you would have less people affected. You also could use this to boost your operational costs because you know now at which of these bones you would have to introduce redundancy, but not leverage this too much. And we also see it very similar what Yuval said. It's actually now the time to move because only if you now prepare your industry or also your company in looking at these problems or identifying those problems, you will be able to solve them for the next hardware generations in 1 or 2 years. When you can actually, or where we will be able to achieve quantum advantage. Another thing that we did is pretty close to what actually QuEra did, is we were using analog quantum computer to boost the performance of a machine learning data set. For this, we actually were using a toxicity data set. So this is a data set, it's a publicly available data set of chemicals where the chemicals are characterized into toxic and non-toxic. This is actually a challenging data set because it's highly imbalanced. So you have much more chemicals in this data set that are non-toxic than toxic. And it's also a restricted data set in terms that you only have very limited amount of data. So very similar to what QuEra has done together with Merck. And what we have seen is that if you run this data set first through analog quantum computer and afterwards put it into a machine learning model, that you're actually able to drastically improve the performance of these models. And here we were actually comparing against really state-of-the-art classical machine learning models, like gradient boosting tree models, or also random forest trees. And a nice thing, what you can see is that you boost the overall accuracy, but what you also achieve is that you actually have a much higher balanced accuracy. So you're able to identify these problems or to identify these classes that are actually underrepresented in the data set. And this is often important, for example, for pharma, where you, for example, have only certain molecules that are bounding, or also for risk assessment in financial sectors, where you, for example, would like to predict the credit risk of some company, and often the credit risk is super good, but now you would like to identify of these only small ones that actually have a high credit risk, and for this you can actually use the methods we have developed here. What we also have now is last summer we actually acquired the Planck platform from Anacor, which was also a startup that participated in the QuAI Ventures accelerator. And by combining our efforts, we now are able to make our algorithms accessible via the Planck platform, which means now they are accessible via seamless API calls. The Planck platform also integrates hardwares. So we are now able to connect our algorithms with different hardwares. For example, QuEra is one of our premium hardware vendors here. And this also allows to create services fast. That's not only restricted to Kipu. So everybody, for example, if you are a corporate and you would like now to develop your own service that's based on some algorithms, you can add that on top of that, and you can create your own API solutions, or even other startups can leverage our solutions and with that produce their own solutions. If you would like to engage with us, or if you got interested and would like to know more, we are really happy if you would reach out to our customer team, for example, Matthias and Robert. They're always happy to discuss. Thanks a lot.
Thank you very much, Jan. As we come to the end of our webinar today, although we selected the participants based on geography, we go sort of region by region. It's really interesting that together with our partners, we really covered the full spectrum of enterprise needs. If you just need initial education or a hackathon or incubation, then of course QuAI Ventures is a fantastic solution. If you need application development or usage of existing applications, then Kipu Quantum can help. If you need classical quantum integration, hybrid algorithms, then QMware can help. And of course, we're really glad to be associated with these three companies, and they and their customers and their partners use our amazing quantum computer. So in this International Day of Quantum, I thank you very much, Alexandra, Marcus, and Jan, and thank the audience. Please join us. The next webinar that we have is on April 30th. It's on algorithmic fault tolerance. It's part of the Science with QuEra series, talking about an amazing way to make quantum error correction more efficient. So thank you very much and enjoy the rest of your day.